Hi, everybody. It's Friday, so we're going to try something new today, but don't worry, it's pretty straightforward. And basically, it's just a little death by definition, nothing major. So let's talk about mixtures and solutions. Mixture is two or more substances that maintain their individual properties. So my wife keeps telling me that I need to eat more salads. When I put all the salads together, it's not just lettuce. If you're going to eat a salad, you may as well put croutons and bacon on there. But when I put croutons on there, the crouton touches the lettuce, it doesn't automatically become lettuce. It remains a crouton, okay? It maintains its individuality from the rest of the salad. Same thing with the bacon, thank God, right? Now, these mixtures can be heterogeneous or homogeneous. Heterogeneous is it's mixed unevenly, because think about it, not every bite of a salad is exactly the same. There's a different amount of cheese, different amount of salad dressing, different amounts of bacon, although every bite should have bacon. Just saying, personal opinion. You can disagree with me, but you'd be wrong. And that's okay. You can be wrong. Not every bite has cucumber or crouton or whatever. It's like a layer cake. You've got frosting, then cake, then frosting, then cake. And if you go to the Cheesecake Factory, they have a 7-layered chocolate cheesecake with frosting in between, and it's like $25, and it's like 8 inches tall, and it's beautiful. But I'm not interested in eating it because I don't want diabetes. But that's what a heterogeneous mixture is. A homogeneous mixture is stuff that's mixed evenly throughout, like your air. You don't get one breath that's all nitrogen, one breath that's all oxygen, and one breath that's all sulfur dioxide because the kid next to you let off a silent but deadly. It's mixed the same. You get the same percentage of nitrogen, the same percentage of oxygen in every breath. Sweet tea is the same thing. For all of you going down to the donut shop and getting sweet tea, it's not one sip is sweet and one sip isn't. It's the same all the way through the glass. Okay. Now, a solution is just a homogeneous mixture that's the same everywhere with two parts. You have a solute and you have a solvent. The solute is what you're adding to it to get to dissolve, and the solvent is what's doing the dissolving. So in the case of the sweet tea, the sugar is the solute, and the tea, the liquid, is the solvent. Anytime you're putting a solid or a gas in water, the solid or the gas is the solute. Water is the solvent every time. Okay? So the little bubbles in your soda are actually solute. All right? And there's a couple of types of solvents or solutions. You can have an aqueous solution where water is your solvent, like coffee, tea, Kool-Aid, lemonade. Even beer is an aqueous solution because it's only anywhere from 3 to 12% alcohol. So technically, beer is an aqueous solution. Okay? In fact, any alcoholic beverage that has less than 100 proof, less than 50% alcohol, is aqueous. If you've got more than 50% alcohol, you're a tincture. That's an alcohol solvent. So if you're drinking, which I know none of you would do because you're all sweet, innocent children who would never drink alcohol underage. But let's say there's a bottle of alcohol in your home that says it's 140 proof. That means it's 70% alcohol. Okay? My wife scored a bottle of 91% rubbing alcohol today at the grocery store. That's 91% isopropyl alcohol and 9% water. If you've ever gotten hurt in my classroom, that little red stuff I put on your cut before I give you a Band-Aid is tincture of iodine. It's alcohol with iodine crystals dissolved in it. Okay? And it's a great little antiseptic, even though it hurts and burns a little bit, but it does the trick. Two liquids that dissolve in each other are called miscible liquids, like alcohol and water. Alcohol and water actually dissolve into each other. So if you take 50 milliliters of water and 50 milliliters of pure alcohol and mix them together, you end up with 97 milliliters of solution because they do one of these things. Okay? They just fit into the grooves and dissolve into each other. It's great. Liquids that don't dissolve in each other are called immiscible liquids, like oil and water. When I grew up in Tucson as a teenager, they switched over from tearing up the asphalt, old asphalt, and putting down new asphalt to something called chip sealing, where they would spray out oil on the road and then dump a bunch of gravel on it and then run steamrollers back and forth over the gravel to make it thick, which it never did. So whenever you drive on it after they've fixed the road, I got the door open, sorry. After they fix the road and you drive on it, it sounds like machine gun fire because of the rocks that your car's picking up, but also because of all the rocks being sprayed on your car by every car that passes you or in front of you, back of you, because that's what happens with chip sealing. But the interesting thing in Tucson is that when they do this stuff between April and June, middle of June starts Tucson's monsoon season. Sorry. Middle of June starts Tucson's monsoon season. And it goes probably through to the middle of September, where it rains every afternoon, every other afternoon. And not just a little bit of rain, you know, where it's like, oh, no. Noah's flood, thunder and lightning. You know, you can get 1 inch to 2 inches of rain in an hour, kind of monsoon. Well, you're driving along in your car, and it's just finished raining, and you go to step on the brake because you come up to a light, and the oil that they had sprayed on the road floats to the top. You go to stop, you can't stop, and you just kind of right through the intersection and get creamed. They have more car accidents from June to September than they do from September all the way around back to June because of this. So, an alloy is a solid solution of 2 or more metals, brass and bronze and things like that. Copper and zinc make up brass. If you go back and look at the space program, when President Kennedy said he wanted to put a man on the moon by the end of the 60s, none of the metals that we used to build the Saturn V rocket existed. We created an entire new class of alloys for the space program back in the 60s. For the Lord of the Rings movie, for the Fellowship of the Ring, the very first one, you know that scene where Bilbo takes the ring and he's got it in his hand and he tips it like this and it falls and it hits the ground and just does one of these numbers where it doesn't bounce? That was a brand new alloy created for that one 5-second movie shot. It took 2 metallurgists 6 months and 7 different metals to create a gold-colored metal that was so dense that when it hit, it would fall over and not bounce. There's still a lot of metallurgy, a lot of alloy making going on even right now, even for something as silly as a movie. Solubility is the maximum amount of stuff that you can get to dissolve in a given amount of solvent at a given temperature. I don't know how sweet you like your tea, but I'm sure there are some of you who like your sweet tea so sweet that if you run out of syrup, you can pour it over your pancakes. You buy sweet tea and then you add more sugar to it. I know, there's always a couple. There's always 1 or 2. There is a limit to how much sugar you can add to the tea. At some point, you reach this solubility maximum where no more sugar will dissolve. Okay? You can keep adding it. It just sits like a sludge at the bottom of the glass and stares at you. I'm not going to dissolve. Okay? There's 4 things that can affect how quickly something dissolves. It's called the rate of solution. And it's affected by 4 things. And the first one is the size of the particle. Big stuff takes a lot longer to dissolve than little stuff. So it's the difference between sugar cubes, granular sugar, and powdered sugar. Powdered sugar dissolves faster than granular. Granular dissolves faster than sugar cubes. So the smaller pieces will dissolve faster because you have a lot more of the pieces. You have a greater surface area to come into contact with the solvent. So more of it's exposed to the solvent faster, so it dissolves faster. Stirring. Duh. The more you stir it up, the more liquid comes into contact with the solute, the faster it dissolves. And these two, the first two here, they work hand in hand. They're like this. Okay? So if you stir it up with really small particles, they dissolve really, really quick. How much you've already got dissolved in the solution. The closer you get to the max, the slower it goes. If you've ever been in an elevator that's already got 4 or 5 people on it, and you try to get on, and people start adjusting, and then more people get on, and everybody has to keep moving around and adjusting. You ever seen those movies with packed subway cars in New York or Japan or wherever? That's what we're talking about here. You know, you have to take a few extra moments to get all the extra people on board. Same thing here. You can add that first or that second packet of sugar at the restaurant to your tea, and it'll dissolve pretty quick. That third one, you got to stir for a while. Fourth one, fifth one, they take even longer to dissolve. So, you know, it does take extra time. Okay? Finally, the last one, temperature. Higher temperatures not only give you faster dissolving, but they increase the amount you can dissolve, because the liquids are actually farther apart. There's more room in between the water molecules to stick stuff in there. Okay? And you can see this with, pardon me, with water. If you boil some water and pour it into a clear glass, you can probably add 3 or 4 tablespoons of sugar, maybe even 5. Stir that up, and as the water cools, the water molecules will get closer and closer. They will literally squeeze the sugar back out, and it'll snow in the middle of the glass. Okay? You can get a lot more sugar to dissolve in hot tea than you can in cold. Okay? All I'm giving you today is definitions. Your homework, your assignment right now, is to make sure you finish the test, finish the lab, and finish the 6 assignments from the last week and a half. Okay? 2 weeks. Get everything done, because next week we only have 3 days, and then we go on spring break. So I want you to take today and get all of the other stuff done before spring break. All right? Be good, and I'll see you next week. If I can stop it.